What we have here is we want to do this is like your standard optimization problem. This is like the one that's done over and over and over again. So we have a figure above represents a square sheet of cardboard with side length 40 inches. So it tells you that this entire thing is 40 inches, and that's going to be relevant information. So 40 inches. Then it tells you the sheet is cut and pieces are discarded. When the cardboard is folded, it becomes a rectangular box with a lid. So we should see this, that if I fold up this piece right here, right? If I fold up this piece right here and this one right here, right? You should start to see that I'm going to be getting a rectangular box. And I fold up this piece, right? This piece, then I'm going to get that rectangular box, and then of course this one's going to come on top, and then this piece will be the lid, this piece right here. Now, let's see what other information. So that's the general idea of how we have that. Now it's saying the pattern for the rectangular box with the lid is the shaded in the figure, right? So that's all the pieces that are shaded are going to be the box. 4 squares with side length x and 2 are discarded from the cardboard. Okay, now we want to find out which of the statements is true. And it's going to talk about the maximum volume that you have here. So it's not true that in all the ways that in depending upon the x value that you choose, that's going to lead to different volumes for this box. So basically what we should start to see is what's going to happen here. So first thing I want to solve for is I actually want to solve for this length right here. I know, okay, I want to solve for this length, and that's tricky. So how are we going to get this? Well, let's think about this. This length is x, right? And if you look, this length right here is going to be the same length as this length. So let's call this y. Okay? And I know something about the relationship between x plus y plus x plus y. That first of all is going to equal 2x plus 2y equals a total of 40. When I divide by 2, I get x plus y has to equal 20. And then that forces y, whatever y is, I just chose y randomly, it doesn't make any difference. Y is always equal to 20 minus x. And then this length is just 20 minus x. I don't know why I put x squared, sorry. X. And now, if you see, right, do I have all the dimensions for my volume? If you look carefully, you can see that volume they give you is length times width times height. Now, if you fold this box up along here, the height just becomes this value along here. So let's go through in different colors the various dimensions. So let's do the height dimensions in green. So this is going to be a height dimension. That's a height dimension, right? This is a height dimension. This is a height dimension. And then this is the height dimension. And then this is a height dimension. And then this is going to be a height dimension. And then this one. And then there's, let's say, I don't know, the blue that I was just using. This here, right, this blue is the same as this bottom blue over here. And that's like a width. So I have a width and I have a height. Now I need to get a length. And the length is this last dimension right here. And then that'll give me everything. So now let's solve for this length. And we just have to take our time. We have to remember that this original box is a square, right? So I know that this length is x. This is the length I want to find. So I'll put a question mark instead of y. It doesn't matter. Okay? And then this length is x over here, right? This green length. I know, again, that this is a square. So this entire length is 40. So x plus question mark plus x has to equal 40. So x plus question mark plus x has to equal 40. And this means 2x plus question mark has to equal 40, which means that question mark is just 40 minus 2x. And now I have my length. And I have length 40 minus 2x. I have my width is 20 minus 2x minus x. And then my height is just x. And with this, I can get a formula for volume in terms of x, because I know my length is 40 minus 2x. My width is 20 minus x. And then my height is x. And now they're asking me which of the following statements is true, and they want to find out minimum, maximum, minimum, maximum. Okay, so let's find the derivative of this function, and let's find out where its mins and maxes are and see which one of these statements is true. So in order to do that, I'm going to first FOIL this all out. You could use product rule a few times, but I'm just going to FOIL it out. So 40 times 20 is 800. Minus 40x minus 40x plus 2x squared times x. I'm just going to distribute that x again. So now I got a function for v of x. It's going to be equal to 800x minus 80x squared plus 2x cubed. And now I differentiate. So v prime of x is going to equal 800 minus 160x plus 6x squared. And then now here I could factor out what? I could factor out at least the 2. But I'm going to have to factor this quadratic. And that's going to be maybe a little bit of a pain, but let's figure it out. So we have 2 that can come out. I'm left with 3x squared minus 80x plus 400. Okay, I'm going to do the AC method. 3 times 400 is 1200, multiplies to 1200, but adds to negative 80. So multiplies to 1200, 60 and 20, right? Negative 60 and negative 20. So then I split this along those lines. So I say 3x squared minus 60x minus 20x plus 400. And it's all times 2 at the end, but the times 2 won't even matter because you're trying to maximize this function, but we'll see because we got to set it equal to 0. So then now I get, this is going to be 3x, and I'm left with on the inside x minus 2 minus 20 x, did I mess up? 400, 20, minus 20, sorry, because it's going to be, I take out a 3x, right? There's going to be 20 left over here, good, okay, minus, plus 20. Oh, no, I took out a minus 20, so it's going to be minus 20 here, good, okay. So we're all good, I factored correctly. And then this is 2, and I'm going to get that this factors completely as 2 times 3x minus 20 times x minus 20. And this is v prime of x. Now where is it that this equals 0? When x equals 20 is an easy one, and then when x equals 20 over 3 is the other one. Now, we draw the number line, and let's see what we have when we draw the number line. So if I draw the number line, let's go down. So I draw this number line. Here's my number line. And then now let's see what values I have that are key. So the values that are going to be key are going to be, you have, let's say this is 0, let's say this is 20. 20 over 3 is somewhere over here, let's say. Okay, pick a value to the left of 20 over 3. So to the left of 20 over 3 is 0. So I plug in 0. Do I get a positive or a negative? I get a positive. So then that means that the volume of this box is increasing all the way up to this 20 over 3 value, where it stops increasing. Now the question is, does it continue to stop increase? Does it continue to increase after that, or does it decrease after that? So you have to pick a value between 20 over 3 and 20. So what's a value between 20 over 3 and 20 over 3 and 20? For sure 10, right? 10 is going to be, so 20 over 3, right? If I do, how many times does 3 fit inside 20? Less than 10 times, right? So 10 is in between these two, right? 6 or 7, this is between 6 and 7. 20 over 3 is between 6 and 7. It's 6 and 2/3, right? Yeah, this is 6 and 2/3, this 20 over 3. So 10 is between that. So let's see, 10. It's 30 minus 20 is 10. And then 10 minus 20 is negative 10. So the whole thing is negative. So now I found something. Now I found that it's decreasing from 20 over 3 to 20. My function, the volume. So the volume is increasing, and then it's decreasing, all the way up to this 20 value. Now let's see what happens when I go more than 20, so 30. This will be positive because it'll be 90 minus 20, and then this will be positive, so it's going to be increasing after that. So I have it where at 20 it goes down to the bottom, and then it hits, and then it begins to increase again. So this is the max, and then this is a min. So you usually want to maximize the volume of a box given a certain amount of material, right? That's essentially what this problem is asking, and this is a very real-world application. You're a shipping company, and you're shipping a product. You want to use as little of the material to ship your product as possible because you don't want to buy more of this material. So you buy a 40 by 40 piece, and then the question is how do you fold it so you maximize the volume, maximizing the amount of product that you can ship, right? So in this case, yeah, it's a very real world problem, and you want to find the max. So which one says this? It says that when x is 20 over 3 inches, the box has a maximum possible volume, and this one is true. Okay, none of the other ones are true. Look, when x is 20 inches, it has a minimum possible volume. Okay, why is this not true? The minimum possible volume, though. Why is this one not true? This minimum is only going to be a relative minimum. It's not going to be an absolute minimum. If you cut such that x is going to be greater than a certain value, well, wait, when x is 30, shouldn't it be that if x goes off, the volume of the box hits a minimum, and then that's it? It can't be any more. Oh, okay. Okay, so this is misleading, right? We have to be careful, because why is it that this one is not gonna make any sense? When x is 20 inches, okay, what happens is that x goes to over here. So look at this figure here. So x being 20 inches is this length right here. And no box can even be formed at that point. And this positive indication is only saying that if you had a negative length. It's not possible. X cannot be greater than 20. This cannot happen. Because then there'll be no box for you to form. If you cut out this square, right, then this square, then you just cut the square into 4 different pieces. Because this length is 40. So if x is 20, then there's no box. So you can't even make a box for A. So it's a good thing we started going through that each one of these is false to see how it applies to our reality, because it looks like, right, that like, oh, this is the minimum that the box can be. The box is going to 0. the volume is like literally, and then the volume 0 right here. And then after that, you can't make a box. If you could do something like make a negative length, then the volume of the box would magically like actually be increasing, which is weird, yes. But we don't need to worry about the abstract idea of like negative lengths. We never deal with the idea of a negative length. So this is like, no, this is nonsense. Now let's see. When x is 20, the box has a maximum. No, the box can't even have the x can't even be 20. When x is 20 over 3, the box has a minimum possible value. No, the box has a maximum possible value at 20 over 3. So it's not this one. It is D for sure.